We indeed thank our Lord for giving this day and having this webinar session. Now it's my pleasant duty to welcome Dr. S.R. Xavier Rajaratnam, Head Department of Chemistry, Sacred Heart College, to take over the proceedings and propose the welcome address. Over to you, sir.
Thank you, Dr. Collins. A very good morning to one and all. It really gives me pleasure to welcome all of you for this webinar. As in the prayer song, I have to thank thee for giving this wonderful opportunity. First, let me welcome today's resource person, Dr. A. Charles from Pillai Engineering College, Nagapattinam, Associate Professor. So when we go through his profile in the Google Scholar, Sir is having wonderful publications and also very good H-index. So we know Sir, even before some years back, Sir was working with us. Sir is a very good researcher in the phytochemistry. So I hope Sir will definitely share his experience and his speech will be a mind-blowing one. So on behalf of the Department of Chemistry, Sacred Heart College, and also Department of Chemistry, Auxilium College, I welcome Dr. A. Charles, the Associate Professor of Pillai Engineering College, Nagapattinam. Next, I have to welcome the most Reverend Father Joe Alex, our correspondent and secretary for this program. I have to welcome also our principal, Dr. Maria Antoni, who is the backbone for every activities. So he is the main resource, a person, a modern digital person. This guidance only we are doing all these works. So I welcome our principal, Reverend Father Maria Raj, and I have to welcome our additional principal, Reverend Father Maria Arikium, for this program also. Like that, I have to welcome Reverend Sister Jay Shanti, the principal, Auxilium College, for their entire wonderful cooperation. I have to welcome Dr. Jancy Mary, the HOD of Auxilium College, and also Dr. Rosalind Mary, the PG HOD, and other participants. So definitely this will be a very good program. I hope you will enjoy the program and we will gain more knowledge. So once again, I welcome all of you, all the participants. Thank you. Now over to Dr. Collins.
So thank you, sir, for your warm words of welcome. Now it's my pleasant duty to welcome most respected Reverend Dr. Jay Shanti, the principal of Auxilium College, to give her felicitations. It would not be an exaggeration if I say this webinar is a brainchild of Sister Dr. Jay Shanti. Therefore, I request Sister to give her felicitation. Over to you, Sister.
Good morning, everyone. Respected secretaries of Sacred Heart and Auxilium College, Reverend Father John Alex and Reverend Sister Alice Katie, Principal and Additional Principal, Reverend Dr. Maria Antin Raj and Reverend Dr. Maria Arika Raj, Heads of the Department, Dr. Xavier Rajaratnam and Dr. S. Jancy Mary, Convener of 3 days webinar, Professor R.K. Napoleon Raj, Organizing Secretary, Dr. V. Collins Arun Prakash, eminent resource persons, and the motivated and enthusiastic participants. I'm very happy and privileged to be with you during this webinar and to felicitate. All of us may know that plants have formed the basis of sophisticated traditional medicine system that have been in existence for thousands of years to address various diseases, some of which I can tell. For example, diabetics, CNS disorder, malaria, tuberculosis, dementia, Alzheimer's disease, cough and cold, skin diseases, stomach ulcers, wound healing agents, cancer treatment, antibacterial, antiviral, antifungal agents, etc. And Protective effects are due to several components which have distinct mechanism of action. Plants are very valuable as source of a wide range of secondary metabolites. These metabolites are used as pharmaceuticals, agrochemicals, fragrance, colors, biopesticides, and food additives. On the basis of studies carried out in recent years, all of us may know that people are moving from allopathic treatment to homeopathic, Siddha, Unani, etc., which has the plant product as a basis. The goals of these medicines are to treat the whole person. That means mind, body, and spirit. It also aims to heal the root cause of illness, not just stop the symptoms. The 3 days webinars jointly organized by the Department of Chemistry, Sacred Heart College, Tirupattur, and Auxilium College, Vellore, is a common platform for the experts and the researchers to understand and to deepen our knowledge on principles and practices of phytochemical research. I'm sure many young minds will be motivated to carry out their research findings in plant products, which may be a good contribution to the scientific world and to the humanity to eradicate many diseases, including COVID-19, which we are suffering at present. I'm happy to congratulate the heads of the department, Dr. Xavier and Dr. Jansi Mary, convener, Professor Napoleon, organizing secretary, Dr. Collins, and the faculty of Sacred Heart College and Auxilium College for jointly organizing this excellent webinar with great speakers. I heard from Dr. Collins that responses are very good. So I wish and pray that God's blessings may be on each one of us, especially during this webinar, to make it a grand success. God bless everyone. Thank you very much and all the best for the organizers as well as for all the participants as well as for the speakers. God bless everyone. Thank you and have a pleasant day.
Thank you, sister.
Sister, thank you so much for your words of blessing. Sure, with your blessings and prayers, this webinar would go on well, and we wish that participants also will be benefited through the knowledge dissemination made through this webinar. Thank you so much, sister.
Sure, sir. All the best for all of you.
Thank you, sister. Thank you.
Yes.
Without wasting much time, I now hand over the session to the moderator, Dr. Diana Sangita. Over to you, ma'am.
Good morning to all. Once again, I welcome you all to day one of this 3-day webinar on phytochemical research. Now we will go into the session with a small introduction about this research person, Dr. A. Charles. He had done his graduation and post-graduation in St. Joseph College, Trichy, and MPhil in Kumbakonam Government Men's College. He had done his doctoral research in extraction and isolation of naturally occurring compounds from some medicinal plants, and also he had done the in vitro studies on antimicrobial, antioxidant, and in silico studies on HIV-1 protease inhibitor subunit by natural derivatives, anti-inflammatory, analgesic, and anti-proliferation active. He has 3 years of experience in computational chemistry in Jubilant Biosys Private Limited, Bangalore in the year of 2004 to 2007. He started his teaching career in our esteemed institution, Sacred Heart College, Tirupattur in 2007. Now he is working as assistant professor in EGS Pillai Engineering College, Nagapattinam. During his teaching career, he had so far published 22 papers in phytochemical research in national and international journals. Not only this, he had also presented 17 papers in national and international conferences. With this small introduction, I invite Dr. Charles to present his talk on the topic of research avenues in phytochemistry and bioactivity in medicinal plants. Dr. Charles?
Yes, ma'am. Hello, ma'am.
Sir? Okay,
Ma'am?
sir.
Yes, okay. Shall we start, ma'am?
Yes, sir. Yes.
Okay, ma'am. It's audible, ma'am?
Okay. Yes, yes, yes. Is audible.
Thank you, thank you, thank you, ma'am.
Thank you, sir.
So very good morning to everyone. Now we start our topic, research avenues in phytochemistry and bioactivity of medicinal plants. A small introduction about the phytochemistry concept. Today, the introduction is the medicinal plants are of great interest in the field of drug discovery. The most bioactive constituents in the plant is alkaloids, terpenoids, phenolics, etc. Today, the production of number of pharmaceutical compounds are plant-based derivatives, and recent studies are focused on the isolation and identification of some new therapeutic compounds from higher medicinal plants for their medicinal properties to heal certain diseases. So now we go to introduction, a great deal everyone knows the phytochemistry. The father of phytochemistry is J.B. Harvard, composed the definition is the phytochemistry or plant chemistry has developed in recent years as a distinct discipline between organic and plant biochemistry. It is very closely related to natural products. It deals with enormous variety of organic substances that are elaborated and accumulated by plants, and also deals with the chemical structures of their substances, stereochemistry, dynamic aspects, reaction, their biosynthesis, turnover, and metabolisms. The major thing is look at our chemistry perspective, the stereochemistry, the dynamic aspect that is called as biogenesis, how to plant synthesize that secondary metabolites, the natural distribution, and the biological function. Now we go to the definition of natural products. Natural product is the broadest sense, cannot be all chemical compounds which occur in nature. It is now used to refer only to the organic compounds occurring in nature. They are further defined, restricting the term to the primary and secondary metabolites. It focuses on the chemistry of these compounds and thus keep the subject under the umbrella of organic chemistry. So today the medicinal plants are of great interest in the field of biotechnology, as most of the drug industries depends upon these plant metabolites for the production of number of pharmaceutical compounds. The many drugs commonly used today are herbal origin because their safety, their quality, and efficacy. Herbal drugs, nutraceuticals, food supplements, folk medicines, pharmaceutical intermediates, and new chemical entities, sweeteners, flavor, fragrances, pigments, and a number of healthcare related products from plant origin. In phytochemical world, the general protocols to be followed is the plant, selected the plant, particular day, particular harvesting time, maybe that during the harvesting time, maybe summertime or in the winter time, the ground plant is dried in dark place and goes into powder mass, and finally we go for solvent extraction. The solvent extraction come into that various non-polar to polar solvents like N-hexane and ether, ethyl acetate, and methanol, like that. And further fractionations, the simplified the extract undergoes chromatograph. This chromatograph is a very good art, is the main source for the separation science for complexity, and go to the crude compound. The further crude compound may be purified by preparative TLC and HPLC, like that. And finally, we get pure compound, pure compounds in order to achieve as a chemist to determine the structure, and that structural things we go to the bioactivity studies. Next. The general technique of medicinal plant extraction in the phytochemical world, macerations, infusion, percolation, digestion, decoctions, and hot continuous extraction in Auxilium method, aqueous alcoholic extraction by fermentation method, counter current extraction, microwave assisted extraction, ultrasound extraction, sonification techniques, supercritical fluid extraction. Finally, we are followed phytonic extraction. That is, we used only for hydrofluorocarbon solvents. And our research team members, we followed hot percolation method and aqueous alcoholic extraction by fermentation techniques. Next slide. Okay, come to the chemistry perspective. First of all, what is secondary metabolites? The secondary metabolites is the final product of plant. And the other meaning is the secondary metabolite is a non-nutrient for plant. It is nutrient to consumers like animal kingdom and human. So secondary metabolites is equal to non-nutrient content. Now we go to secondary metabolite terpenoid. Everyone knows the definition of terpenoid is a hydrocarbon fully, maybe hydrogenated or oxygenated or dehydrogenated derivatives, or else the polymers of isoprene monomer. So the functional unit is here, maybe isoprene unit is the functional group. Many terpenoids are volatile. It cannot be easily isolable under only for hydrodistillation method only followed by terpenoid isolations. They occur widely in the leaves and fruits of higher plants such as camphor, coniferous, citrus, and eucalyptus. The classification, look at the structure. Based on the terpenoid isoprene units, the hemiterpenoid is 1. It is considered to be isoprene. The number of isoprene is 2. It's said to be monoterpenoid, like the sesquiterpenoid, diterpenoid, sexterpenoid, triterpenoid, and tetraterpenoid. Finally, the polymer rubber. The main functional unit is isoprene. Another important thing is the bioactivity of isoterpenoids. The first topmost seller is andrographoloid. Andrographoloid is a diterpenoid. It is derived from Androcropis paniculata. It is today that antiviral property like this andrographoloid is a top seller in the market. Immunomodulation. Kabasura kudinil irukkudiya main constituents. So another one is camphor, commonly known. It is derived from many Laraceae family species. The camphor is the main constituents, the monoterpenoid. And another food, Zingoga biloba, derived from zincolloids. It is a neuroprotective, like the zerbunum and quasins. Then come to the flavonoid. Look at the chemistry of flavonoids. The main core is the 15 carbon containing compounds. Flavonoid occur in a variety of structural forms. All contain 15 carbon atom in the parent nucleus and share the common structural feature of 2 phenyl rings linked with 3 carbon chains, that is biphenyl propane derivatives. That is 1, diphenyl propane skeleton are regarded as chalcones. The 3 carbon chain may be formed into a 3, 5, or 6 member ring through all oxygen. One of the phenyl ring generating a tricyclic system. Record the skeleton of the structure is hemiacetal linkage, oxygen, the numbering is 1, 2, 3, carbonyl carbon is 4. Then 5, 6, 7 is the fused ring system. Another biphenyl system is B ring. So 3 rings are there, A, B, and C. Totally the carbon is 50. If you isolate the flavonoid compounds, the carbon 13 NMR shows 15 carbons exactly. And the carbonyl carbon peaks at exactly 170 to 190 range. Carbon 13 NMR predictions 170 to 190 is the flavonoid skeleton is there. The carbon 13 is 15 carbonyl, then only go for structural elucidation for flavonoid pattern. The textbook is AP Agarwal, C13 NMR of flavonoids for structural elucidation. More than 12,000 of compounds are isolated and recorded in the LCL publications. If you isolate the flavonoid skeleton, if it is flavone or flavonols is there, go to the textbook and refer the textbook, and you obtain NMR, you compare that and your compound may be matched. More than 12,000 compounds are available. Then 1,2,5-vinyl propane skeleton is isoflavonoid. The benzene ring move towards neighboring to the carbonyl carbon. It is said to be isoflavonoids. That next classification of flavonoids. Classification of flavonoid in the next slides. One is isoflavonones, flavonols, flavonones, flavonols, flavonones, anthocyanin. These are 6 classification. Simply similarity, the chromone moiety is there, and the position of the benzene ring for isoflavone is neighboring to carbonyl carbon. All Choias family and Fabiaceae families, major composition is isoflavone system. And Fabiaceae family and Mimosaceae families, the isoflavone is major constituents. Here, the phenyl system neighboring to the carbonyl carbon. Flavonols, look at the structure, catechin, the carbonyl carbon is missing. And flavonones, double bond is existing, whether flavanol, that's nearby to OH, carbonyl group neighboring to OH. If you go to carbon 13 NMR, the peak is 192 is there if it is flavanol is present. Because highly donating substituent, the OH group neighboring carbonyl carbon, the peak at more than 190 in carbon 13 NMR, it's said to be flavanol is present. Then flavonones and naringenin is the best example. Look at the flavonones and apigenin, the third one, apigenin. The apigenin, the common constituents, the major plants. Apigenin is existed. Apigenin and naringenin, there are 2 differences. Here, double bond is missing and double bond is there, neighboring to phenyl system. Next, the application. Then phenolic acid. Next slide. The plant phenolics, the major application, plant phenolics. Phenolic compounds with bioactive functions found in plant and food products according to their structure. First, hydrobenzoic, example gallic, vanillic, protocatevic acid, syringic acids, and hydroxycinnamic acid system. The best example is cinnapic acid. First one is benzoic acid phenolic compound. Another one is hydroxycinnamyl system. The cinnamic acid and benzoic system, common phenolics in all higher medicinal plants. The application of flavonoids, next slides. We are a topmost flavonoid I listed out in the bioactivity studies. First one is luteolin and mycetin, quercetin, camphorol, apigenin. The first 5 major available in the all plant kingdom. And malvidin, rutin is a glycosidic of quercetin. Rutin is a quercetin of glycosides. And hesperidin, the major constituents in peel of orange. It introduces so many bioactivities present in the flavonoid family. In 21st century, flavonoid is a predominant role for human healthcare activities. Next, we go to chemistry of quinones. Chemistry of quinones, the next slide. Yes, the quinones are a large class of organic compounds such as benzene or naphthalene system, and even number of CH groups into C double bond O groups. That are the major application and the classification is the next slide. Yes. And the naphthaquinones, the naphthyl system is there. It is derived from Alcana tinctora, the first quinone derivatives. Another important one is aloe vera family. And anthraquinone is present. Anthryl system. It is derived from aloe vera. Anti-tumor, antibiotic, anti-HIV. All bioactive principles in aloe vera, such as aloe imodine. If it is cut it off, that aloe vera, after a few minutes, a scarlet red crystallized is formed. That is anthraquinones. Next, go to the lignin. Today, the lignin is the topmost cure may be achieved to the COVID-19. Chemistry of lignins formed linking two phenyl propanide units, C6 and C3 units by oxidative coupling. Lignin, two C6, C3 units are bounded through the central carbon of their side chain, that is the 8 and 8' position. Whether the new lignins, the occurrence of C6, C3 dimer link at sites other than 8 and 8' position. Dear chemist, look out the chemical structure, then only predicted the isolated molecule in the NMR data. Look out the numbering system, conventional neolignans and non-conventional, it is attached to coumarins and flavono or stilbeno lignans are present. The major application, the application of lignin yes. Podophylotoxin, the inhibited topoisomerase 2, these are protease enzymes. Then the third one, anogalin A, it is inhibition of HIV-RT, today market sellers. The plant is Anogolysis accumulata species, and termalignin is an anti-HIV assay using MP4 cell line. Azarin, it is inhibited for various cancer cell lines, and niazole. So the all 12 isolated lignin compounds today as HIV and other viral replication. Look at the structure of the molecule, all are highly symmetrical, highly easily isolable molecules. These are lignins. Maybe the lignin may be curable, that viral replication and immunomodulated system to improve our immune system. Next. Yes. The chemistry of alkaloids, a variety of definition is there. We know that alkaloid is an alkali-like, it's a nitrogenous substances. According to Landenberg says, alkaloids are definitely natural plant compounds and contains at least one nitrogen atom heterocyclic ring and possesses biological activities. According to the characteristics features of alkaloids, basics is a basic nitrogenous plant origin, mostly optically active and possessing nitrogen heterocycles as their structural units with physiological action. According to Peltier 98, alkaloid in cyclic compounds containing nitrogen is negative of oxidation state, which is of limited distribution in living organisms. Then classification of alkaloids. The classification of alkaloids. First, last 50 years, that the alkaloid chemists, researchers, we classified the last 50 years, the review, detailed review is under the classification I slide out. First, ornithine derived alkaloid. This is the very peculiar one. It is called as the laurine. And tryptophan derived. These are amino acid sequence, maximum very rare. This is ornithine derived and tryptophan derived alkaloids. Then everyone knows that nicotine derived alkaloids, tropane derived alkaloids, phenylalanine, tyrosine derived alkaloids, and erythritine alkaloids. Then benzyl phenanthridine. This is the morphine system that is said to be that benzophenanthridine skeleton. It's like a porphine family. Similarly, more than that methyl group is present by and the nitrogen atom is a morphine. The similar structure for porphine derivatives. Then epoxic alkaloid. Another one is purine derivative, highly polar. It cannot be resolvable. It's very complicated to isolate the particular alkaloids. Classification. Another classification is berberine. The berberine derivatives and pyridine alkaloid, pyrazolidine alkaloid, pyrroline type of alkaloid. Another indole type alkaloid in India, top seller is from periwinkle, that is Nithya Kalyani, that is cantharine, inulidine, camphothecene alkaloid, agemelicine are present in periwinkle. This is indole type of alkaloids. Another thing is miscellaneous, very peculiar, and name it the compound, it is easily synthesized also. Next, the application of alkaloids. The topmost, cocaine is a CNS stimulant, major alkaloid in a CNS system like Alzheimer's diseases, analgesic, like morphine, and Alzheimer's disease like Parkinsonism can be cured by this type of alkaloidal families. Finally, quinabalin, antimicrobial properties. And the 28th example, streptozidine is an to inhibit cytotoxicity for A54 cancer cell line. Next. Phytosterols. Look at the structure is highly complicated structure. The structural elucidation is present. More number of phytosterols are isolated and structurally elucidated. But to understand the common structural feature, more than 27 carbon present. More than 27 carbon is present. The total number of carbon is 28. Yes, the phytosterols have a double bonded system, typically between C5 and C6. If it is not present in the double bonded system, it is said to be phytostenols. If phytosterol system is present in the plant kingdom, if it is animal system, is zoosterols. Now we go to the phytosterol classification. The classification of phytosterols. First one is phytosterol is further classified into 5 types. One is camposterol, stigmasterol moiety, avenosterol, cytosterol, and brastosterols. So very common plant system, if steroidal is present, is stigmasterol is present. Then we go to saponins. Saponin compounds a steroid moiety, the C27, triterpenoid system, the C30 is present. If it is a glycon is there, it is said to be sapone. If it is glucose is present, it is said to be saponin. Next, we go to my research work. The last 7 years, under Dr. Alex Ramani sir, my guide, St. Joseph's College, Trichy. Past 7 years of working about that particular plant family, phytochemical and biochemical studies of Alcyodaphne semicarpiafolia niche and Thunbergia fragrans. My research work going to the next slide. The collection and identification of plant extract from the chosen medicinal plants, leaves and barks of semicarpiafolia and Thunbergia fragrans. The specimen is verified by Rabinian Herbarium, St. Joseph's College Autonomous, Tirupattur. The plant species are collected from Colli Hills. The two chosen medicinal plants is available in higher tropical medicinal plants. This is the herbarium material and various parts we listed out. This Alcyodaphne species only available in India, Indian origin, India to Sri Lanka, that Western Ghats. And Thunbergia fragrans is available in Yelagiri Hills, nearby Vellore district, in front of my Sacred College. We collected that particular species. The name is called as Thunbergia fragrans. And in Tamil, we say Ganai Pirandai. Thunbergia fragrans said to be in a Tanni Kodi. The distribution major in Colli Hills, Western Ghats, and Eastern Ghats. The phytoconstituent is Sri Lankan. It is one type of 5,4-hydroxylated apartheid derivatives, and the apigenin and iridide present in the Thunbergia species. The major medicinal uses in Alcyodaphne species, the rinderspest diseases in cattle, and leech bite and blood cancer. And the leaf and bark paste is applied on the region of beetle and scorpion. It can be cholera-like illness and life-threatening virus such as HIV. For Thunbergia fragrance is mostly given to antidote for snake bite. It is detoxification. If it is any toxic available in our brain, a neural system like lead, arsenic, it can be easily removed by detoxification process by this extract. And if it is affected by alcoholic or another drug in the lung, it can be easily removed by this kind of extracts, particularly Thunbergia fragrance. The Thunbergia tea is a major in Malaysian and other Indonesian regions. Then experimental methods, my research work. So for all phytochemistry followed by same protocol to be followed, we collected the plant species and identified to herbarium and confirmed that and authenticated by government of Tamil Nadu by Coimbatore. The solvent extraction process, our research team members to follow that novel way. And the crude extract fractionation, simplified extract, and crude purification process is go to majorly preparatory TLC and column chromatograph. One or two fractionation by HPLC. The structural determination we use the UV, IR, proton NMR, C13 NMR, and mass. In C13 NMR, we goes to depth mode and also HMBC and HMQC. The overall view my research work is bioactivity studies. For bioactivity studies to be followed in silico studies, in vitro studies, biochemical studies, and in vivo studies. The two plant is a new species in India, in our all the world, so that we choose all pharmacological activities, all screening activities we did, lot of work, lot of quantum of work we did my research. Particularly the bioactivity studies, biochemical process, and in vivo studies for anti-inflammatory, and in silico approach for HIV1 protease inhibitor. It's a protein available our net by using our drug discovery studio. And the first extract goes to a Gcms analysis. Today, this was two preliminary research work. On my research work, we helpful to identify some compounds. For example, the ASLE, we find 50 type of compounds to be identified, and chromatogram of TLF, more than 21 compounds are identified. And chromatograph ASB, find 28 compounds are identified. In chromatogram, only for volatile substance only we are identified. Some polar compounds, some polar compounds also execute, but these interpretation all are available only on the based on library compounds available in the major phytocompounds are identified. And the major thing is more or less we are achieved some isolable molecules. The last compounds. This is the type of lignin is identified in the GCMS, and one small polar molecules to be identified in GCMS analysis for the bark extract of Alcyodaphne. Come to my scheme of extraction, separation, and identification of the phytoconstituents of the bark extract. Our team members we choose from the organic separation in a MSc lab. Like that, we followed some modification or did in the new methodology. For example, the powder box of Alcyodaphne come to the ethanolic extraction for cold percolation method for 72 hours. This extract goes to the simplified into two parts, and one is taken to the NaO, it's alkaline medium, another one is acidified medium. We find out ether layer 1, ether layer 2, then ether layer 3 and 4. The results obtained in my present phytochemical work, leaf extracts of Semicarpifolia is the presence of flavonoids and phenolics. And similarly, in the next slide for leaf, same procedure and protocol. And then next, phytochemical screening. The phytochemical screening are followed by Brinda et al. Procedure, and the reagents preparation in our laboratory by my research members. We followed alkaloids, standard procedure and protocol to be followed for the positive response of phytochemical present in our. The results obtained in the present research work, phytochemical investigation of the bark leaf extract Alcyodaphne semicarpifolia, the presence of flavonoids and phenolics in ether layer 2, the presence of basic compounds like alkaloids in the ether layer 4, when the ethanolic extract treated with 4-NHCl solution and further extracted with the ether, the basic compounds were retained in the acidic aqueous layer. The ether layer took out for other polar compounds while neutralizing the acidic aqueous layer with alkaline 10% NaO solution. The basic compounds were liberated. Then these basic compounds were extracted using ether. Thus, ether layer 4 was analyzed to have alkaloid. The acidic compounds like flavonoids, phenolic, and other constituents present in the ether layer 2. When the ethanolic extract were treated with the 10% NaO solution and further extracted with ether. The acidic compounds were retained in the basic aqueous layer. The final aqueous portion treated with highly polar solvent like ethyl acetate and methanol. This is a positive response in my for extract the ASBE, ASLE, and TFL. Next, the details of the isolated compounds. We fix the solvent ratio for preparative TLC and column chromatography. We finding some pure compound for the leaf extract is ethanol, ethyl acetate, water. The universally buffer solution, we obtained some in aqueous layer portions. The semi-carpifoliar bark extract, we followed some TLC system. We finding the 9 compounds in our isolatable pure compounds. These are the chemical studies for isolated compounds very much, but the obtained compound, the nature of the color, melting point, boiling point, and so if it is solubility, either chloroform or acetone or ethanol, solubility test, melting point analysis, and simple chemical test for in order to determine the functionality. For the isolated, the 9 compounds, just 2 preliminary micro analysis in my laboratory. Next. Similar data to carried out TF1, then next slide, and TF2 and TF3. Come to my research portfolio in silico analysis. Totally 125 molecules were screened against this protein. These molecules are alkaloid and iridoid type of compounds. And the 125 molecule is a chemosystematic marker of Laraceae family, Alcidaphne species, and Thunbergia. That core molecule is porphyrin moiety, active, bioactive, and isomeric form of porphyrin derivatives, and one lactone type, and quinoline type of compound 1, and anthroquinoline type of compound. We take the ligand. Overall, the chemosystematic marker compound from the previously isolated molecules, totally we take 125 molecules were screened. The protein data bank is HIV1 protease. The BDV ID is 3HAU. This VU, the active site, the aspartyl group, is a very essential binding site of the structure of HIV protease. Here working is in the drug discovery studio 2.1 lipdoc method. The overall the theme is the binding affinity, high lipdoscope we calculated. The receptor ligand binding affinity, the final score. Based on this principle, we get some idea about the binding site mode against HIV1 protease enzyme. The result is the result. Hernan is we draw the structure Hernan, and standard drug we take the HIV drug, standard drug, Indoneware. The docking score is 140. The number of hydrogen bonds here 2. Here active residues, the docking score of Hernan is 136.127. Whether the thinoloside, the glycoside of iridoid system, the docking score is 122. The above 125 molecules, we get more docking score. The hit score is Hernan give that against the HIV1 protease enzyme. Next. Next, we go to the biochemical studies. It's on the chemical studies only. Antioxidant activity. That is a free radical scavenging procedure. First one is DPPH method. A simple take the extract, add the buffer solution, and add the dye DPPH in the dark room. The absorption was measured at 417 nanometer after 10 minutes against a blank. Another one more assay is hydrogen peroxide scavenging activity. Extract and buffer and add H2O2. We get the 230 nanometer against absorbance already studies. And reducing power assay. The calculation part of view, the percentage of anti-radical activity, A minus B by A into 100. A is the absorbance of control and B is the absorbance of sample. The final result is based on the standard ascorbic acid, we get the IC50 values of and both 3 acids. ASLE, ASB, TFLE got good results, the antioxidant potential. Next. Antimicrobial studies of ASBE, ASLE, and TFLE. Antimicrobial activity against studies various pathogens like 20 bacteria and 6 fungus. The Agarwal diffusion method. The zone of inhibition have been determined by susceptible and resistant values. The respective antibiotics with the smallest zone of inhibition as resistant. The one which largest zone as sensitive. Those in between, it is said to be intermediate. Next. Against the 20 bacteria studies, the largest zone of inhibition is said to be sensitive. I pointed out in the green color, and pale and the blue color, smallest zone of inhibition, it is said to be sensitive. That also called as resistance. The zone of inhibition is more, it is said to be sensitive. The smallest zone is said to be resistant. And similarly, antifungal activity is obtained results. The antifungal activity against 7 fungal species we take, the ASB response, a very good response for antifungal activity compared to other strains, other extracts. Next slide. Cytotoxic studies of ASLE, ASB, and TFLE against the cancer cell line. I take the cancer cell line as A549 cell line. This is a human lung carcinoma. To check the cell viability and what is the proliferation, what is anti-proliferation of extracts study by simple method only. This assay carried over in the MTT type Moser-Money et al. Methods. We get a significant survival of the cell, decrease with increase in extract concentration. About 50% inhibition was found to at 125 microgram. The measured by calorimetric technique. What is the main theme is the viable cells were determined absorbance at 570 nanometer in well plate method. The dye used in INTT is in a dye. Look at the color change. That pink color is converted into yellow. Then you find the absorbance. Based on the absorbance studies, we concluding some remarks. The remark is the IC50 where the minimum inhibition concentration is 125 against cell control, and the ASB and TFLE has got good response for live results. And next slide. Then we go to the pharmacological studies in vivo method. First, you find out the acute oral toxicity. The albuminurides, we find the 150 to 200 grams were used for the studies, and 100 mg per kg were given as a starting dose. The observation we find before we start that research work for chest and skin, fur, eyes, mucous membranes, and also respiratory, circulatory system. Analgesic activity. It brings about the insensibility to pain without the losses of consciousness. ASB, ASLE, TFLE were examined to analgesic activity by hot plate method using male Swiss mice. Pentosozine is a standard drug. When mice place on a hot plate to lick to its hind lip or try to jump out to calculate the time measurement. Only for time measurement. The time measurement is the limb pass jumped out from the escape to the particular measurement. A simple hot plate method only we did. We got ASBE and TFLE got a good results for analgesic activity. The next activities was studied by anti-inflammatory drug. The anti-inflammation subside when the healing is complete. The alcoholic extract was subject to anti-inflammatory act using albuminurides by currently-induced pyoedema method. Indomethacin as a standard drug. Albuminurides of either sex weighing 150 to 250 grams were divided into 5 groups of 6 animal each. Look at the systematic and schematic diagram here. The control saline 2 mg per kg and indomethacin as a drug for 10 mg per kg. ASLE, ASB, and TFLE correspondingly 10 mg per kg will be Dose will be given to the particular rats. We finding a good result against the standard indomethacin drug. ASB got a good result for anti-inflammatory activity by pyrogen-induced pyoedema method. To measure the plethysmometer and how to inflame is reduced. Before go to the studies here, you follow the in vitro studies by SRBC membrane stabilization studies. For in vitro method, the easy procedure you can do it in your laboratory. The concluding remarks, the phytochemical screening revealed that terpenoids, flavonoids, tannins, alkaloids, and some glycosides were found to be present in a semicarpifolia tea fragrance. Interestingly, results of titers studies using extracts of increasing towards cancer treatment due to valuable phytochemicals present in these extracts. The antioxidant activity studies revealed that you get good result for radical scavenging activity. That concentration of ethanolic extract leaves of semicarpifolia maximum inhibition towards the microbes and very good fungal activity also. The extract of tea fragrance and effective inhibition towards the microbes and against 20 bacteria and 6 fungus species. And the isolated compound is, we find the isolated compounds and the leaf extract, we get the flavonoid glycosides. It is a highly polar compounds. It is only available in the aqueous medium from the ethyl acetate fractionation. The flavonoid glycoside structural determination using the AP Agarwal textbook based on the carbon 30 NMR, HMBC and HMQC techniques. And proton NMR is enough to bring about this type of flavonoid glycoside, unique glycosides. Another, the bark extract, we find out the lactone type of compounds. This lactone type of compound is a chemosystematic marker for the Alcyodaphne species from the bark, that is butanaloid. This is a common name for lactone system. And one terpene compound and one benzyl isoquinol alkyl type of compound isolated, one phenolic acid like protocatevic acid, the well-known compound, and one more quinoline type of compound isolated from the bark extract of Alcyodaphne. And come to that Thunbergia fragrance extract, we find one iridiol, but one double bond is missing here. So we can calculate structurally isolated. It is maybe based upon the iridiol. And methoxyflavonones. The methoxylated flavonode is easily isolable. If it is OH is present, it's complicated. Methoxylated is a symmetrical methoxyflavone base. It can be easily soluble in the ether layer itself. It can be crystallized easily, the particular extract, for example, the TFLE. And one more cinnamic acid glycoside is present. Overall, we find concluding the 9 compounds is present in our research work. And my references followed by first standard references, Matthew K in the Flora of Tamil Nadu Carnatic. The references, very important thing is, Matthew is a reverend father in the herbarium in charge. Starting my research career in 2004, father is very supportive to my research work in St. Joseph's College, Rabbinian Herbarium, Tirupattur, India. That textbook is available in herbarium. You go and refer the first book and choose it the medicinal plant. You consult the botanist, then only start your research career. Otherwise, as a chemist or biochemist, first of all, you consult that Rabbinian Herbarium in St. Joseph's College. The father is there, Father Brito is there. Go and discuss and select that medicinal plant and confirm that the family belonging, which family, everything said to be in a Brito father and other research team member in St. Joseph's College. The standard reference book is Matthew KM, the Flora of Tamil Nadu Carnatic, Rabbinian Herbarium, Tirupattur, India, and Gamble, the Flora of Presidency of Madras. These are the first 2 standard books for starting your research work. Then standard book, textbook followed by J.B. Harborne book for the phytochemical methods and isolation techniques and preparative TLC, either go for chromatographic techniques. Harborne discussed elaborately in the particular textbook. You can easily follow. And my paper presented in the conference from starting from 2012 to 2016. And Shastra University people very helpful to do the research work. And list of paper publication. And my list of paper publications and my conference presenting. One more tips given to my researchers. followed by phytochemical databases. Duke phytochemical databases present in the Google Scholar and Google Network, and various phytochemical databases available in the net. You first searching the database, then you start your research work and consult the botanist and prepare the plan in phytochemical phenol, either work is complete or not. If isolation process, if flavonoidal work, Dr. Sukumar sir is there. You discuss any structural pattern, go to prepare in the Agarwal textbook. The structural elucidation is very complicated today for alkaloid and other terpenoid compounds in and around South India. If you go for Kamaraj University, natural product group is there. Go and discuss your NMR rates. Then mass spectrometer and LCMS is available in Sastra University, and go give your extract. They give the chromatogram report and various library compound matching is given. Thank you for listening for all researchers, and thank to Reverend Father Rector, Sacred College, Tirupattur, and the arrangement organized by Napoleon sir and Colin sir and moderator Diana ma'am. And once again, thank to my research guide, Dr. Alex Ramani, and my animator, Dr. Sukumar sir, for this particular past 17 years. I carry over my research in the field of phytochemistry. Thank you one and all for my listening. Thank you.
Thank you, sir. Thank you for your presentation about the various natural components present in the medicinal plants and their biomedical medicinal values, which was very informative and useful for all of us. We have few questions from the audience, sir. One question from the Zoom. From Sai Kritika. What is the result we get from in silico analysis? Why do we perform that?
In silico approach, before starting your research work, in vitro studies or in vivo studies, before you start first in silico approach, you're finding the particular docking mode and particular protein molecules. The result is the Lipdorf score. We're finding the hydrogen bonding mode. How much the ligand sites, how much interaction, the hydrogen bonding interaction we studied. From the score, we concluding the remark is our molecule able to do the either drug or not for the particular diseases and incurable diseases like that.
Thank you, sir. Anybody? Anybody from the audience? You have any questions? Please unmute your mic.
Hello, sir.
Yes, madam. Hello.
Tell me, ma'am.
Madam, tell me.
Hello.
Yes, ma'am.
Yeah, hello. Hello, sir. I have a doubt regarding the authentication of the plant species which we selected for the phytochemical analysis. How can we authentically say that it's a medicinal one? Actually, I selected my medicinal plant from traditional way, that is from a tribal people. But how can we authenticize this? Or do you get my point, my question?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Ma'am, if you choose your plant and go immediately for particular nearby colleges or particular department, botany department, and confirm the name first. Either the family species are there, or maybe the species are rare species, maybe the species are new species, maybe the work is done or not, and check it out botanist first, nearby botany department college. Or else you get good authentication, come for St. Joseph's College, Trichy. The herbarium is there. The largest herbarium in our zone. Reverend fathers are there. Research members are there. You can come and give the authentication report.
Okay.
If you go for Tamil Nadu Agricultural Department in Coimbatore, they give you the authentication. Or come for Annamalai University, the Department of Botany, they provided authentication report. Your herbarium is deposited at a particular institution. They give some number.
It's a grass species, sir. That's the major problem. It's a grass species. Hello.
Family, ma'am. Family name, ma'am.
Grass species, which is I selected a grass.
Okay,
Genus name is okay. Can I tell my genus name? Oh,
ma'am. Basically, I'm a chemist.
okay.
Best of all, you approach that your botanist member. Before you start your research work, plant species selected, you
Okay.
go and report it nearby botanist. Best you go for St. Joseph's College, Trichy. They give lot of information regarding this, and go for Wealth of India textbook. Wealth of India textbook.
Actually,
Everything
I'm
is
a
there. Everything is documented.
sir. Actually, I'm from Kerala, so can I
Okay.
mail them first?
Sure, ma'am. Sure, ma'am. If you take the photograph, you take the herbarium, then you have to give to someone. They give the some help.
Okay, sir. Thank you.
If you நீங்க நேரா டைரக்டா போறதா far best. Your presence is must directly. Then only you got a lot of information in the St. Joseph's College. They give a lot of support also.
Okay.
Thank you, ma'am. Thank you,
Okay,
ma'am.
okay, ma'am. Thank you, ma'am. Charles, sir, we have another question. Which particular phytochemical is responsible for microbial activity?
Maximum the phenolic groups. Maybe phenolic groups are responsible for antioxidant, antimicrobial, and antifungal. Because the phenolic in the functional OH group will able to do the resistant activity. Maybe the phenolics and flavonoid type of compound, very good result compared to other phytochemicals. Phenolics and flavonoids.
Okay, sir. Then another question from Manjula Madhyalagan. Sir, is it possible to use plants for preparing metallic nanoparticles?
No idea, ma'am. No idea, ma'am. No idea, sir.
Okay, sir. Thank you, sir.
Not that level.
Okay, sir. Thank you, sir. Xavier, sir. Sir.
So first of all, I want to thank you for the very good presentation. So thank you, sir. Thank you for the presentation, sir. Just I have one.
Dr. Charles.
Yes, sir. Savi, sir. Thank you, sir.
So, thank you, sir. Just I have one doubts on layman's doubt. Sir, in the plant extract, we are having different type of groups, flavins, isoflavins, phenols, like that. My question is, if the functional group may oppose, because one is good in analytic studies, another maybe has some other property.
Yes, sir.
Will they oppose will they oppose each other? Is it like that? Suppose one common property may be opposed or suppressed by the other compound, the same extract. Because in the allopathy, we are using the pure compound.
Yes, sir. Yes, allopathic. Yes, sir.
In the Siddha and other things, we are taking the extract, crude extract.
Yes, sir. Yes, sir.
So will all the compounds will cure one disease, or one will cure the another will have some other effect?
Oh, sir. இப்போ சித்தா யுனானி ஃபோக் இந்த மாதிரி ட்ரெடிஷனல் மெடிசன் சிஸ்டம் எல்லாமே டிகாஷன் ஆவோ இல்ல சிரப்பாவோ இல்ல டேப்லெட்ஸ் ஆவெல்லாம் கொடுத்து பழகிட்டு இருக்கிறாங்க. பட் வி கெட் மேஜர் ப்ரொபோஷனல் மோர் பயோஆக்டிவ் கான்ஸ்டிட்யூயன்ட் பிரசன்ட் இந்த பர்டிகுலர் சிஸ்டம். That compound will be able to do. அதான் என்னோட கெஸ்ஸா இருக்கும்னு நினைக்கிறேன். ஆக்சுவலி இது கெஸ் தான் இது.
அதான் எனக்கு ஒரு காம்பவுண்ட் ப்ராப்பர்ட்டி இன்னொரு காம்பவுண்ட் சப்ரஸ் பண்ண மாதிரி தான் எனக்கு டவுட் இருந்தது.
சப்ரஸ் பண்ண வாய்ப்பு இல்ல.
Thank you, sir. Thank you.
No feedback.
Thank you, sir. Thank you for your informations.